Hey there, I was just about to finish this last problem before I get interrupted, but we're going to go ahead and solve for x here. So I'm going to multiply both sides by 0.07. I got negative 0.1316. And then add 1.84 to both sides. Gets us to here. Just think about all the rounding they've been doing throughout this. I'm going to go ahead and say that it's rounding this to the 100th is what they've been doing. So 1.71. So Mr. Wilcox would need to have a run of 1.71 minutes to be in his fastest 3%. I guess or less, huh? All right, so that's the end of those from 2.4 through 2.6. A couple other questions kind of related to 2.4, so like assessing normality. I think one of the bigger ideas with this unit, so like how do we know if a distribution is normal? Because if we do know it is normal, then we can use the empirical rule. We can use the table A, z-score business to find proportions, percentiles, probabilities, things like that. So we need to know if a distribution is normal first. And so here we have the distribution of ages that students reply. So when I sent out that survey that you guys took, 363 students replied from across the school. Tell me how old they were in months, and so here I collected that data and in this distribution. So is this distribution of ages approximately normal? And so the three visual cues are, is it single peaked? Which this is it roughly symmetrical? Sorry about my handwriting here, but you'll figure it out. Which this is not, and then is it approximately bell-shaped? And so if we run that curve through here, is that bell-shaped? Like, this is not really going to look like a bell at all, so no. So as I know, the distribution is not approximately normal. Because it is not roughly symmetrical or bell-shaped. So we wouldn't bother doing the math test on this. Speaking of that, so another distribution of data. This is from the heights that you guys gave me in inches. And so is this distribution approximately symmetrical, or approximately normal, sorry. So basing the answer on the graph and then the empirical rule. So the graph, when we say that is it single peaked? Yes, it is single peaked. Is it roughly symmetrical? It's pretty close to being symmetrical. It's a little bit. You see the median is 67, the min is 62, the max is 70. So it's close. It's a little bit longer on one side or the other, but we should check it. It's not it's a little bit skewed. It's not way off. And then is it bell-shaped? And so if we draw the bell or the curve, does it look like a bell? It's fairly bell-shaped. So it's kind of it's pretty close to hitting the targets for the the visual target. So I want to go ahead and check the math. It's not way off. So we need to create the intervals here for this. And I showed you guys 2 ways in the class days, but I'm just going to do this the first way I showed you. So I'm going to take the mean, which is 67. We're going to add, subtract the standard deviation once from that. Then we're going to take the mean and add, subtract 2 of the standard deviations. Then we're going to take the mean and add, subtract 3 of the standard deviations. And like I told you guys in class, I would suggest doing the subtraction one first, because we want the lower value on the left side, so when we do intervals. So that gives me 64.306. And then do subtraction of 2. I'll do 3. So what we're going to do is go back and look at the data and see what happens here. So we have an interval. Want to find any students that are between 64.306 inches tall and less than 71.098. So I need them to be bigger than 64.03. So 64 is not bigger than 64.3, but 65 is. I need them to be shorter than 71.098. So 71 inches would be there. So I'm going to count all these students here, or it's going to be easier for me is I got 57 total, so I know there's, let's see, 8 here that are not, and then 10 here, so that'd be 18 out of the 57, so 39 that are not, sorry, 39 that are, so 39 out of 57 fall within that window. And I want to do a similar thing with the next interval. So I want to figure out what percent of students fall on here. So bigger than 60.9, which all of these students are bigger than 60.9. Less than 74.4, which is going to be here. So only everybody but 1. So that would get me down to 56 out of 57. And the last interval from 57 to 77. So everybody's shorter than 77 inches, everybody's taller than 57 inches, so that's everybody there. And so obviously that's 100%. 56 divided by 57. That's 98.2%. And 39 divided by 57. 68.4%. So those were supposed to match the empirical rule, which is 68, 95, 99.7, and then within 4% is kind of the rule of thumb. So that's within 4% of 68, that's within 4% of 95, that's within 4% of 99.7. So it does seem to fit the empirical rule, and so it's close on the eye test, and it fits the empirical rule. So we're going to go ahead and say that this distribution is normal. So let's say the distribution, and then you want to have context of, I'll say student heights is, and we always say approximately normal. We don't say it's normal because it doesn't exactly fit. And you want to say because. You want to mention the 3 visual criteria. It is single peaked. It's roughly symmetrical. And also approximately bell-shaped. And the values of the data closely follows or closely matches the empirical rule. So this is the, I say again, the more time-consuming, most time-consuming thing we did all unit. So like a big honkin' sentence you got right here. So again, like context. What's the question about? Is it approximately normal? And then we have the 3 visual criteria. And then we have the math behind the empirical rules. So hopefully that helped a little bit. I'll see you on the test.